Okay, we're going to start the notes for chapter 3.1, and we're going to be talking about symmetry and coordinate graphs. So we've been working with coordinate graphs already with our graphing, but let's just revisit what the word symmetry means. So symmetry is another way of thinking symmetric. So a parabola would be symmetric. That means it's the same on both sides. Another way to think of it is if it's foldable. Can I fold this in half and it line up exactly on top of each other? That's one way to think about it. A circle would have symmetry. An isosceles triangle, it would have symmetry down the middle. So anything that's foldable. All right, so let's look at this first one. The first thing we're going to look at is point symmetry. So basically what we're talking about with point symmetry is if I pick any specific point, so like on this S, I'm going to pick this point M. If I can rotate it 180 degrees and it looks exactly the same, so I'm going to take this piece of paper and I'm going to rotate it 90, 180. This S looks exactly the same way that it did when we started. Therefore, I can say that it has point symmetry around point N. Now this line, if I pick N as my point symmetry and I rotate it, and it doesn't matter which direction we go when it comes to 180, we can go 90, 180. Does it look exactly like it did when we first started? Yes. Therefore, it does have point symmetry at point N as in Nancy. Let's look at this graph. If I pick the origin and I rotate this graph 90, 180, it looks exactly the way it did when we first started. Okay, so all three of these examples have what we would call point symmetry. Okay, if we looked at these graphs, we would want to try to find a common point where we would have symmetry at. So just by looking at this first graph, if I rotated it 90, 180, it looks exactly the same. So it does have point symmetry. We just have to figure out where that point is. Okay? A very good place to start on most of these graphs are going to be at the origin. Okay? So in this case, this one is at the origin. Now, if this was shifted to the left, to the right, up, or down, this point is going to go with it. Okay, same thing with this one. Right now, if I was to rotate this 90, 180, it looks exactly the same. Since this has not been shifted, and this is my parent graph, the point symmetry is going to be the origin. Now, if I had shifted this left, right, or up or down, this point is going to move along with that. But as of right now, we are showing point symmetry at the origin. So, maybe we don't have a graph, and maybe we are just given an equation, and they want us to decide, is this thing going to have symmetry with respect to the origin? Okay, so they give us a lot of this great definition, but some of this information we probably don't know how to process yet. So there's some notation here that we need to talk about. When they talk about points A and B, that would be like your inputs and your outputs, your X's and your Y's. This fancy, what looks like an E, means the elements of. That just means that something, whether it be our X's and our Y's, our inputs and outputs, belong. That means they're an element of the set, okay, the solution set. So that's what this S stands for. This is kind of noted up here, okay. I've changed the A and the B to X's and Y's because a lot of times that's what we're used to thinking of in terms of inputs and outputs. This is element of, or you can think of it as that it belongs to. Okay, and this is the solution set. Now, they've made this really fancy, but the main thing to remember is this right here is what we are trying to prove. Okay, so we need to know that if we take f of negative x, meaning I replace every x in my function with negative x and set it equal to negative f of x, which means I'm going to negate the entire function If I end up with these two being equal, then I can say I have symmetry with respect to the origin, okay? It's going to make a lot more sense if we see an example, okay? So this is what we're going to use, okay? So let's move on to an example. All right, so here's my function, f of x. So in this one, f of x equals